ethers. An ether is a compound in which the oxygen is in between two carbon atoms. It has this sort of V shape that the molecule of water has. And instead of having the oxygen attached to two hydrogens or even one hydrogen like the alcohols, you have it in between two carbons. They are polar compounds because the sharing of electrons between the oxygen and the carbons is not evenly shared. The oxygen is firmly controlling the electrons, so it's pulling from the electrons from the bonds, and you have like a concentration of negative charge, partial negative charge around that oxygen. So they are polar compounds, and they can be slightly soluble in water because water is a polar solvent. When the carbon chain is too long, they become quite insoluble. They can't form hydrogen bonds because to form a hydrogen bond, you need a hydrogen directly attached to an oxygen, which is then close to another atom of oxygen or fluorine or nitrogen from another molecule. And here you don't have any hydrogen directly attached to an oxygen, so no hydrogen bond. When we talk about ether, we think about one specific type of ether, which is the most common one, which is diethyl ether. So there are a couple of ways of naming them. One is the common one, which is so common that it's actually accepted formally by the UPAC, International Union of Pure and Applied Chemistry, which is the organism that sets the rule that we chemists follow, for example, to name compound. So the common name of naming them is calling them ether, and then in front of the word ether, you mention the two alkyl groups you've got. Like for example, the first one on the left, this one here, you have two ethyl groups attached to the ether, so you call ether, and you use the prefix di because you have two groups, and methyl because they are methyl groups. So dimethyl ether. The one in the middle, diethyl ether, is an ether. You have the oxygen in between two ethyl groups, and the last one, you have an ethyl group and a methyl group. You put it in alphabetical order: ethyl, methyl, ether. That is not how you name it. Sorry, in the UPAC rules, you name it slightly different. What do? You pick the longest carbon chain and you call that with the alkane name. So in this case, the longest carbon chain is methane. In this case, it would be an ethane, and in this case, the longest carbon chain is an ethane. And apologies, I need to put a name here. So your compounds are going to be a methane, or the other two an ethane. And then you name the bit on the left-hand side, the bit with the oxygen, as an oxy group. So it's going to be an oxymethane, an oxyethane, or an oxyethane. And that oxy has attached to it the other bit of the substituent. So it's an oxygen that has a you name basically the shortest chain as the substituent. So that would be, the first one is a methoxy group, the second one would be an ethoxy group, and the third one would be again a methoxy group. And that's how you call it. That's what I was saying, made a mistake there. You should not say ethoxyethane on the last one. It should say methoxyethane. Apologies, that's a copy and paste error. So that's how the UPAC proper name is. You will see that the common name, the name in both alkyl chains as some alkyl ether is the most common one.